Typhoon Saudel is turning over open water about 348 kilometers east of Saipan, and it is strengthening by the hour. That is roughly the distance from London to Manchester, all of it deep ocean. Forecasters now expect this storm to reach 220 kilometers per hour within 60 hours. That is Category 4 equivalent on the American scale, the fourth strongest category of storm that exists. Less than 24 hours ago, Saudel was not even a typhoon. On the afternoon of August 21st, it was a severe tropical storm with 110 km per hour winds. By 8 p.m. Philippine time that same evening, it crossed the typhoon line. One evening, one classification jump. The U.S. Joint Typhoon Warning Center is already forecasting 178 kilometers per hour, the major typhoon threshold, within hours. This is not a routine storm passing through. Something unusual is happening in this stretch of the Pacific, and the people of Japan and Korea are now directly inside the forecast path. Today we break down how Saudel became a typhoon this fast, why the track is genuinely uncertain, and what happens if it makes landfall. No guessing, no dramatizing. Just the facts, the science behind this storm's growth, and the real stakes for millions of people in its path. If you live in Japan, South Korea, or Okinawa, or if you have family there tonight, drop your location in the comments. We are updating this story as the track becomes clearer. Subscribe to Earth Dispatch now because Saudel develops fast over the next 48 hours, and we cover every track update and every intensity change as it happens. Start with the water east of Saipan. Saipan is the largest of the Northern Mariana Islands, a U.S. territory in the Western Pacific with roughly 43,000 residents. Move your eye 348 kilometers east of that island into open sea and you find Typhoon Saudel. It carries the Western Pacific designation number 18 for the 2026 season. The word typhoon is not decoration, it is a measurement. A tropical cyclone becomes a typhoon when its sustained winds reach 119 kilometers per hour, the same threshold that makes a hurricane in the Atlantic. Saudel crossed that line yesterday evening and it has not stopped climbing since. Walk the timeline backwards and the speed of this becomes hard to believe. Around August 17th, forecasters were tracking an ordinary blob of disorganized thunderstorms and gave it a working label. Tropical Depression 17W. A tropical depression is the weakest stage of an organized ocean storm with winds under 63 kilometers per hour, weaker than the gusts in a strong thunderstorm over any city. On roughly August 18th and 19th, it tightened up, gained a closed circulation, and earned a name: Saudel. At that point, it was simply one more tropical storm in a crowded ocean. As late as August 20th, the Japan Meteorological Agency measured Saudel at 75 kilometers per hour, with a central pressure of 996 hectopascals. That pressure reading matters, because lower pressure at the center means a stronger storm, and 996 is barely below the ordinary pressure of a calm day. Then came August 21st. That afternoon, the Philippine weather agency PAGASA clocked sustained winds of 110 kilometers per hour with gusts to 135 kilometers per hour, strong enough to flip an unsecured car door back on its hinges and strip roofing sheets from a home. By approximately 2000 local Philippine time that same evening, PAGASA confirmed typhoon strength. That is the part meteorologists are focused on right now. Saudel jumped a full classification during a single evening in the window between dinner and bedtime for anyone watching from Manila or Guam. It is currently moving north-northwest at 22 kilometers per hour, roughly the pace of a person on a bicycle, which sounds slow until you remember it is carrying a rotating storm field hundreds of kilometers across. The Joint Typhoon Warning Center, the U.S. military forecast office that tracks every Pacific system, expects Saudel to reach 178 kilometers per hour within hours of this broadcast. That number is the major typhoon threshold, the point where damage stops being expensive and starts being structural. The first official warning is already out, and it is not for Japan or Korea. The National Weather Service office in Guam has issued a typhoon watch for Alamagan, Pagan, and Agrihan, three of the smaller northern islands in the Marianas chain. These are sparsely populated volcanic islands, home to only small numbers of residents and researchers, with no hospitals, no shopping centers, and no easy way out once the sea turns. A typhoon watch means sustained winds of 120 kilometers per hour or greater are possible within 48 hours. For islands that size, that is not an inconvenience. That is isolation. Saudel is also arriving inside a season that has already been busy for months. Forecasters projected an above-normal 2026 Pacific typhoon season with around 28 tropical storms, and by the middle of August, 17 had already formed. Saudel is the 18th. To put that in human terms, the Western Pacific has been producing named storms at a pace of roughly one every 10 days since spring, and each one demands evacuation plans, ferry cancellations, and school closures somewhere along the Asian coastline. The season has produced monsters. Typhoon Sinlaku struck the Marianas in April 2026 with peak winds of 280 kilometers per hour, a Category 5 equivalent, killing 17 people and causing about $458 million in damage. That storm ranks among the strongest April typhoons ever recorded. Then between August 7th and August 9th, Typhoon Dolphin passed through the Okinawa region and made landfall on China's Zhejiang coast, having peaked at Category 4 equivalent strength just 11 days before Saudel formed. Counting Saudel, this is the fifth major tropical cyclone to threaten the Ryukyu Islands in roughly 3.5 months. Saudel, by the way, is a name contributed to the regional naming list by Micronesia, one of dozens rotated through the Western Pacific list. But here's the question that matters most. Saudel became a typhoon in a single evening, and forecasters expect it to keep growing. What is happening in this stretch of ocean that feeds a storm this much energy this quickly? Meteorologists have a formal term for what Saudel is doing, and it comes with a hard number attached. Rapid intensification means a tropical cyclone's maximum sustained winds increase by at least 30 knots, or 55 kilometers per hour, within a single 24-hour period. Think of it as a storm going from moderate to severe in the time it takes you to sleep, wake up, and go to work. Saudel is forecast to exceed that threshold, not just meet it. 3 separate conditions are converging over this patch of ocean, and each one removes a break that normally keeps storms in check. The first is the water. Sea surface temperatures east of the Mariana Islands are currently running above 30 degrees Celsius, which is 86 degrees Fahrenheit, warmer than most heated swimming pools. Warm water is the only fuel a typhoon has. The storm draws energy from the ocean through evaporation, lifting warm, moist air into its core, where it condenses and releases heat that drives the whole engine faster. Below 26 degrees Celsius, that process weakens badly and storms starve. Above 30 degrees, the fuel supply is effectively unlimited. There's a deeper detail that forecasters watch even more closely, called ocean heat content. That is not just how warm the surface is, but how far down the warmth reaches. A typhoon churns the sea beneath itself like an enormous mixing spoon. If the warm layer is thin, the storm drags cold water up from below and cools its own fuel, which is why many promising storms stall out. East of the Marianas right now, that warm layer runs deep. Saudel cannot mix up anything cold enough to slow it down. The second condition is what is missing overhead. Wind shear is the change in wind speed or direction at different altitudes, and it is the main thing that tears developing storms apart. When winds high above a storm blow hard in a different direction from the winds at the surface, the storm structure gets sheared sideways like a stack of plates pushed off center. Saudel is sitting in a low shear environment. The air above it is calm and consistently aligned, which lets the storm stack its thunderstorms into a clean vertical column and build a tight, efficient core. The third condition is the one that explains the speed. Forecasters have confirmed dual-channel outflow. Outflow is a typhoon's exhaust system. The storm pulls warm air in at the bottom, lifts it, and then has to vent that heat and air out through the top and sides. When those exhaust pathways are open, the engine breathes freely and accelerates. When they are blocked, the storm chokes on its own heat and weakens. Saudel currently has 2 clear channels, one venting toward the northeast and one toward the southwest. That is an overheating engine with 2 open exhaust pipes. There's a larger pattern behind all of this. The 2026 season is unfolding under a developing El Niño, a periodic warming of the tropical Pacific that forecasters project may rank among the strongest on record. El Niño does 2 things to typhoons that matter enormously for Asia. It shifts the zone where storms form eastward, further out into open ocean, which gives each storm more warm water to cross before it reaches land. It also pushes the recurving tracks northward, aiming storms at Japan, Korea, and eastern China rather than the southern Philippines and Vietnam. That is precisely why Japanese forecasters expected an above-normal number of typhoon approaches this year. The climate backdrop is factual and worth stating plainly. Sea surface temperatures across the western Pacific have run above their historical averages through 2026, which means more fuel available to more storms. Roughly 80% of tropical cyclones that reach Category 3 or stronger go through rapid intensification at some point in their life. Global climate records show these rapid intensification events have grown more frequent as ocean temperatures have climbed. Saudel is not an exception to the pattern, it is the pattern happening live, which brings us back to the forecast. The Joint Typhoon Warning Center puts Saudel's 60-hour peak near 220 kilometers per hour, a Category 4 equivalent on the U.S. scale, or a very strong typhoon in Japanese terminology. The Japan Meteorological Agency's own projection has Saudel down to 940 hectopascals of central pressure by August 23rd, with sustained winds near 90 knots and gusts to 130 knots. 2 agencies, 2 methods, same direction of travel. The storm is growing, and the science explains why it is growing this fast. But here is where the story becomes genuinely urgent, because meteorologists cannot agree on where Saudel goes next. And the gap between the options is the gap between 3 different countries. Three major forecast agencies are watching this storm, and after August 25th, they diverge. The Japan Meteorological Agency, the U.S. Joint Typhoon Warning Center, and the Korea Meteorological Administration each have a different answer for where Saudel ends up once it clears the Ogasawara Islands. That level of disagreement is not normal for a storm already this well organized. It is the direct consequence of something that broke in the atmosphere over the western Pacific this week. The confirmed part of the track is straightforward. Saudel is moving north-northwest at 22 kilometers per hour, roughly 348 kilometers east of Saipan. It passes near the northern Mariana Islands through August 21st and 22nd, tracks toward the Ogasawara Islands, Japan's remote southern chain about 1,000 kilometers from Tokyo, by August 23rd, and sits south of Japan by August 24th. After that, the map opens up. The reason is the subtropical ridge. That is a large dome of high atmospheric pressure that parks over the Pacific and behaves like a wall, deflecting typhoons and steering them along its edge. For most of mid-August 2026, this ridge sat unusually strong, herding storms along a consistent path. Over the last few days, it has weakened and started to break down. Remove the wall, and Saudel loses its steering guide. The storm will simply follow whichever pressure gradient opens first, and nobody can yet say which one that will be. Option 1 is Japan, and it is the most frequently modeled outcome. In this scenario, Saudel recurves northwestward toward the Ryukyu chain, the long string of islands running southwest from Kyushu. Okinawa sits directly in that corridor with 1.47 million residents, a population comparable to the city of Philadelphia, packed onto an island 106 kilometers long. Okinawa averages 7.7 typhoon approaches a year, so residents there are among the most storm-experienced people on Earth. But Typhoon Dolphin struck them at Category 4 strength only 2 weeks ago. 2 major typhoons inside 3 weeks would be historically unusual, and it would hit an island still repairing roofs and restoring power lines. Push the track further north, and Japan's main islands, home to about 125 million people, face surge, flooding, and wind. Option 2 is South Korea. Korea Meteorological Administration forecaster Woo Jin-gyu specifically named Korea as a possible landfall target, saying, "Since the North Pacific high is still expected to expand and contract while the typhoon moves northwest, we'll need to keep monitoring where it heads after August 25th. If the subtropical ridge partially rebuilds to the south, it would deflect Saudel northward straight at the Korean peninsula. South Korea has about 52 million people, most of them concentrated in dense coastal and river valley cities. Korea sees 1 or 2 significant typhoons in an average year, but direct major landfalls are rare. Typhoon Rusa in 2002 caused $4.3 billion in damage there, equal to 0.72% of the entire national economy that year. A Category 4 equivalent direct hit would be extraordinary. Option 3 is Eastern China. If Saudel turns west sooner and sharper than models currently expect, it could reach the coast of Zhejiang or Fujian province, the same stretch that absorbed Typhoon Dolphin's landfall 2 weeks earlier. Those provinces hold tens of millions of people across low-lying delta cities and industrial ports. Because the current models spread so widely, Chinese emergency planners would be working with very short notice. Here's the honest measure of that uncertainty. The Joint Typhoon Warning Center's forecast cone, the area within which the storm center is likely to fall, has a radius of about 40 nautical miles at day 2. By day 5, that radius grows to 180 nautical miles, roughly 335 kilometers. That produces a possible spread of about 670 kilometers across at the 5-day mark, wider than the distance from Okinawa to Kyushu. This is not a failure of forecasting, it is an acknowledgement that the atmosphere has not made its decision yet. The ridge will move over the next 48 to 72 hours, and when it does, the track sharpens fast. While Japan and Korea wait, the Marianas are already inside the window. Alamagan, Pagan, and Agrihan sit under a typhoon watch issued by the National Weather Service in Guam, based on the threat of sustained winds of 120 kilometers per hour or greater within 48 hours of this broadcast. For island communities, that small resupply ships and evacuation flights stop long before the first strong gust arrives. The track will clarify, and when it does, one of those countries will be facing a direct hit from what could be one of the most powerful typhoons of this season. Let us talk about what that actually means, based on history and on the current forecast. A typhoon carrying sustained winds between 178 and 220 kilometers per hour does not simply pass over a coastline, it rewrites it for months. At 178 kilometers per hour, well-built frame homes lose large sections of roof and suffer structural wall damage, windows fail, signage becomes airborne. At 220 kilometers per hour, most trees along the track snap or come out of the ground entirely, power poles go down in long rows, manufactured homes are destroyed outright, and even solidly built houses can lose their roof structures completely. Rebuilding a regional power grid after that kind of wind field takes weeks, not days. The wind is rarely what kills the most people. Storm surge usually is. Storm surge is not the rain and not the wind. It is the ocean itself, physically shoved inland by the typhoon's rotating winds and its low-pressure center. Water weighs about 1,700 times more than air, so a moving wall of it flattens what wind only damages. For a Category 4 equivalent typhoon, coastal surge of 4 to 6 meters is possible depending on the angle of approach and the shape of the coast. Okinawa's flat southern shoreline, where most of its population lives, would be exposed. So would Korea's western coast, where the shallow Yellow Sea allows surge to pile higher before it lands. Then comes the rain. A typhoon of this size can drop 300 to 500 millimeters of water along its track, which is 12 to 20 inches or several months of normal rainfall in a day or two. Japan's steep mountainous terrain funnels that volume into narrow rivers and drainage channels within hours. Landslides are a primary killer during Japanese typhoons, and in several major events they have taken more lives than the wind or even the surge. History in this exact corridor is unambiguous. Typhoon Vera struck Japan in 1959 and remains the deadliest typhoon in the country's recorded history, killing more than 5,000 people and destroying 833,000 homes. It moved through the same general region Saudel is now threatening. Typhoon Hagibis, far more recent, made landfall south of Tokyo in 2019, killed at least 99 people, flooded wide areas of central Japan, and caused $17.3 billion in damage. In Korea, Typhoon Rusa in 2002 caused $4.3 billion in losses on a direct peninsula landfall. These are not abstractions. They are infrastructure events measured in years of repair. Season context matters too. Saudel is the 18th named storm of 2026. Typhoon Sinlaku's April peak of 280 km per hour still stands as the year's strongest. Saudel's forecast peak of 220 km per hour is about 79% of that number, which is still powerful enough to be catastrophic wherever it lands. And Saudel would be the fifth major tropical cyclone to threaten the Ryukyu Islands in roughly 3.5 months. That is not a coincidence. That is the signature of a season shaped by El Niño. Being expected by the science does not make any single storm less dangerous to the people underneath it. 3 things are worth watching over the next 2 days, and they give you a framework instead of just anxiety. First, track confirmation. Watch whether the subtropical ridge rebuilds to the south, which would push Saudel toward Korea, or opens to the north, which would steer it into Japan. Second, the intensity check. If Saudel runs into dry air or rising wind shear early, that 220 km per hour peak comes down. If current conditions hold, it may be met or exceeded. Third, watch the agencies. When the Japan Meteorological Agency and the Korea Meteorological Administration begin issuing official coastal watches within the next 24 to 36 hours, the track has largely resolved. The next 48 hours will tell the story. Saudel is not weakening, it is growing, and somewhere in the western Pacific, a coastline is about to learn exactly how much. Think about the morning of August 21st in Tokyo, in Busan, in Naha. Commuters filled train platforms, parents packed school bags, shopkeepers opened shutters in ordinary late summer heat. Nothing about that morning suggested anything. Meanwhile, in forecast offices in Guam, Tokyo, Manila, and Seoul, meteorologists watched satellite loops all day as a moderate tropical storm tightened, cleared its outflow channels, and crossed into typhoon strength before their shift ended. The storm changed category in one evening. Almost nobody in its possible path knew it yet. That gap between what the data already knows and what people have heard is the whole reason this video exists. The information is not missing. It is already on the screens of 4 national weather agencies, and it is pointing in one direction: a strengthening typhoon, an open track, and 3 heavily populated coastlines waiting on an atmospheric decision. The question was never whether the data would arrive in time. The question is who chooses to listen while there is still time to act. Preparation happens before certainty, not after it. Now tell us something useful. Are you in Japan, Okinawa, or South Korea as this storm approaches? Are you following this track for someone you love? And here's what we really want to hear. What does typhoon preparation actually look like where you live? What do people in storm regions do as routine that viewers elsewhere would never think of? From taping windows to filling bathtubs to securing rooftop water tanks. Put it in the comments because that knowledge helps somebody reading them. Subscribe to Earth Dispatch because Saudel keeps developing over the next 48 to 72 hours, and we will be here for every major update, every track shift, every intensity change, and every warning upgrade as it happens. This is not the last video on this storm. And if you know anyone in the path right now, share this with them. Getting the right information early is the difference between prepared and caught off guard.